Hi everyone. Today we'll present our work on building a conversational speech model for Arabic and English. Current speech models are good at tasks like text-to-speech, but they can't really converse. Real conversation needs understanding of emotions and social context, not just producing audio. What is missing? Unified representation for emotion and styles, conversational level understanding like turn-taking, and generation that adapts to the user states plus. Arabic is underserved in our current speech AI. Our goal is to build a model that actually listens and responds appropriately. Recent systems like Sesame Speech GPT and Cozy Voice show that real-time conversational speech is feasible, but most work focusing on the intelligibility and style, not on understanding user emotion across multiple turns and adapting accordingly. So our approach has three parts. Build an automated pipeline for labeling emotions and Discord roles, create a holistic evaluation framework, and train a model that generates speech aligned with conversational context. To address the lack of conversational ability, limited Arabic support, and weak multi-turn understanding. Our automated pipeline segments audio, uses multiple ASR model to generate transcriptions and align them at world level. It gives us the foundation for extracting conversational annotation at scale.
For Arabic TTS voice cloning model, we follow 4 steps. Data preparation from multiple sources, followed by encoding the audio with new codec. Then we set up the training architecture and hyperparameters based on the new TTS architecture. And then we have a comprehensive evaluation. We have 3 datasets. 1. A single podcast episode. 2. 13 podcast episodes. And the third one is an audiobook. We scaled the training data significantly. We first began training on 238 samples from one podcast episode. We then expanded to 3,600 samples, followed by around 700k samples from the audiobook. In order to train our Arabic voice cloning model, we fine-tuned new TTS, which is a voice cloning model based on the Qwen 2.5 0.5 billion model architecture. It is very small, lightweight, and can be used for CPU inference.
For evaluation, we use different datasets for English and Arabic. For English, we use LibreTTS. We use the datasets test split to compute our baseline metrics. For Arabic, we use the Arabic Speech Corpus, which is an open source dataset consisting of 1,813 recordings and transcriptions of spoken Arabic language. We evaluated our pipeline on 100 samples, 50 Arabic, 50 English. Gemini achieved the best performance at 4% word error rate overall, 71% better than Whisper. For Arabic, Gemini reached 6.16 word error rate, a 40% improvement. Importantly, Whisper is free and open source, while Gemini is paid. Despite the cost difference, Gemini's superior accuracy makes it worthwhile for high-quality TTS training data. For TTS pipeline, we use Gemini transcriptions to ensure the highest quality training labels. We calculated 2 baseline metrics for the new TTS architecture, word error rate and cosine similarity. Word error rate was calculated by running inference on new TTS to create a synthetic voice, for which we later ran automatic speech recognition with our selected model to create the synthetic transcripts to compare against the real transcripts. For computing cosine similarity between our synthetic voice and the original voice recordings, we use RedimNet, novel neural network architecture for audio processing that extracts utterance-level speaker representations. The results show the performance of the new TTS model over which we are trying to improve.
After fine-tuning on the Arabic audiobook dataset for about 150,000 steps, we achieved a word error rate of 35.25% on Arabic, which is a significant improvement from our English-only baseline. Let me play a few samples for you, along with the reference audio, since this is a voice cloning model.
وليد معروف طبعا ما شاء الله تبارك الله أنت من أبرز الأسماء المشهورة.
صباح الخير. سأذهب إلى السوق لشراء بعض الخضروات. مرتب اليوم هو الأول من ديسمبر.
As we can see, the speech is clear and natural. While we are at 35.25% word error rate right now, this is expected to decrease since we have completed only 3 epochs of training. We are also exploring the gated delta-net architecture for linear attention. This offers O of n time complexity with constant KV cache as opposed to the quadratic time complexity of standard attention. This makes it much more efficient for long-form conversations while maintaining quality.
For future work, we'll continue TTS training on large-scale data with the new gated attention architecture. On the data side, we'll complete the automated annotation pipeline with environmental labeling, quality filtering, and speaker diarization, and explore acoustic-aware fusion strategies to improve transcription quality. These are the references we use, primarily the new TTS model on which we performed our fine-tuning, linear attention for efficiency gain, Qwen architecture for a hybrid attention architecture approach, and eSpeak, which is an open-source tool for phonemization that can work well with our Arabic.